Okay, good morning, everyone. So this is the DNSSEC session, and this session also will be webcasted. So just for the benefit of the people who are joining from remote locations, I will try to stay in one place and also try to avoid moving around and so on. So just yeah, apologies for that. And the other thing is I will try to take any questions because I'll continue through the presentation, and then I will take the questions if you have any questions at the end so that we don't have any interruptions in the middle, right? Just for the recording purposes. All right, I think the main objective of this session is to talk about DNS security and with a focus of DNSSEC, right? So just to introduce myself, I'm Champika. I have a very long name. You can just call me Champ or Champika, right? And I work for ICANN. ICANN stands for, it's a very long acronym as well, Internet Corporation for Assigned Names and Numbers. At ICANN, we work very closely with RIRs, so this is one of the very, collaborative event. We normally, work very closely during APNIC, APTLD meetings, and so on. So it's very nice to see you all here, and look forward to working with you all. Okay. So this is the kind of agenda that I just try to go through this tutorial, this session. I want to obviously thank few people, like especially the DNS security, DNSSEC team, or the security team at ICANN as well, Rick Lamb, and basically the people who has contributed to some of these materials, some of these slides. So I just want to acknowledge them. So what we want to do is maybe probably we'll go through some, just in case if you are new. Okay, so let's get started with the content that what we want to talk about during this session. I'll try to just give a very brief, quick recapture, just in case if you are very new to DNS, how the DNS queries resolve and work, and then we'll discuss why we talk about this mechanism called DNSSEC or DNS security extensions. And then we'll go through how it works, what are the new technologies that we have to deal with, things like new concepts, new resource records, and so on. We'll also actually discuss about some of the signing processes involved, because we work with keys, we do the signing and so on. So we'll go through that process. And then if we have enough time, I will just try to show you some bit of demo, so that how you get a feeling about how these things work. Okay. All right. Just to make sure, how many of you are like new to DNS, just in case? Don't worry. This is a training, so feel free. Okay. I saw a few hands here and there. So let's get, just to tell, how the DNS works. Now, first of all, DNS is a distributed database, right? So it is, you can call it a database. And we have a very hierarchical structure in DNS because if we are going to have this distributed database, it is very important that we manage these namespaces in a proper way, right? So in a database, what we have, simply you can call it as a namespace or even a database. So what we have, they're all names or names to or one type of resource we are trying to map to another type of resource. Say, for example, we are trying to map a name to an address, or even we could do that other way around, mapping an address to a name, right? So these kind of mappings we have in this database. So because if you're talking about data from data communications point of view, if I want to send some data from one machine to another machine, say from my machine to another machine, obviously I can still do that as long as I have the IP addresses, right? That is the layer 3. But we need DNS because we all humans and we can't remember these IP addresses. So that's why we have names so that we can remember the things, right? So we have DNS, right, or domain name system basically. So if it is a database, now we have to have servers that we keep this database. So these servers are simply we call as name servers. So we have namespaces, then we have name servers that we keep these names or databases. Now there are different types of name servers we talk about. Say for example, we have something called authoritative name servers. So what are these authoritative name servers? They are basically the name servers that can give authorized answers or reliable answers, right? So these type of servers are called authoritative servers. So say for example, if you run your own zone, you get a domain name and you run your own zone. Say if it is myzone.net, right? So you can run your own authoritative server for that zone. As probably you know, one server is not really the good thing to do. You need to have some redundancy. So you would want to have multiples of authoritative servers. You could be having your primary, you can have your secondary or multiple secondaries and so on, right? So which means you will have multiple authoritative servers for your own zone, okay? We even call those as masters or slaves, same thing, right? Primaries or secondaries. Then also we have something called DNS resolvers. So what are these? These are, you can even call those as DNS recursive servers, say for example, or even caching servers and so on. Now these servers, they go and talk to many other name servers out there in the DNS and then find the answers for the clients, right? So that's the job of a recursive or resolver or a caching server, right? So those are the other type of name servers. So when we have these name servers, how does a query get resolved, right? So if we have a client, I mean, we know that we use DNS on a very regular basis, all the time, whether if you go and browse a website or whether you go and use your mobile app or whether you send an email, anything, right? So you use DNS, okay? And when you do these type of DNS queries, so we get all the time, we get queries from the clients or the resolvers. So if, say, a client is going and asking a resolver or a caching server, I need to visit, say, in this example, it is www.example.net. So if the client is asking that it needs to visit this website, which means the client has to go and talk to the web server. So that means the client has to know the IP address of the web server, right? Once the client goes and talks to the web server, then it can download the web page. So that's the objective of the client. That is why the client is asking the DNS server, the local DNS server or our resolver, that the client want to get the IP address of the web server. So simply the query is for an IP address for that name. The name is www.example.net, right? So now in this case, where does this query go? I mean, where the resolver go and talk to. Because DNS is a hierarchical system, right, or a database. We have something called root on the top, right? In this hierarchy, we have root on the top. So what is a root? So root itself, you know, that's another database, and then we have a server to keep that database, right? So this database is called obviously the root zone, right? Root zone. And then root zone is kept in servers called root servers, right? So the client, the resolver then go and talk to the root server asking the same question that its client want, right? So the query goes to the root server, and our question here is give me the IP address of www.example.net, and then this question is being put to the root to get the answer. Now, do you think the root can give us the answer here? Probably not. Why? Because this is a hierarchical system, and the root has delegated its responsibility to many other parties, because we have a hierarchy there. So what is this hierarchy then? So after the root, we have what we call top level domains, or TLDs, right? TLDs. So in TLDs, we have again different types of TLDs. Like we have generic top level domains, or we call it as GTLDs, like .coms, .net, and .edu, and so on. Then we have country code top level domains, like .id for Indonesia, or .sg for Singapore, and .my for Malaysia, and so on. So these are country code top level domains. Then we have, nowadays we have even new GTLDs, the new ones like .brands, okay? And then also we have even IDNs, right? The internationalized domain names, and so on, okay? So these are the delegations that we have in the TLD level. So which means the root has delegated parts of its responsibility to many other parties, or in this case, many other name servers, right? And then we go through the same hierarchy again. If you take, say, the .net, right, .net zone, so the .net zone has further delegated its responsibility to, say, for in this case, example.net, right, anything .net. So that's how the hierarchy works. So when this question is being asked from the root server will say, okay, I don't need the IP address of the, exactly the IP address of www.example.net, but root can give the IP address of its child, right, the delegated party. So which is, in this case, .net name server. It could be one name server, or it could be multiple name servers, right? And then the resolver can go and talk to these .net name servers. Now these .net name, any of these name servers not necessarily has to be in one place, one data center, right? It can be all scattered around. We know that, right? It could be in one, multiple places. It could be in different countries, and so on. So more the differentiations that you have, like places that you have, then you achieve more redundancy. Okay. So when this question goes into the .NET name server, in this example, .NET name server will say, okay, I don't know the IP address of www.example.net, but you can go and ask what? You can go and ask the example.net name server, because that is the delegation that they have done for its child, right? So then the resolver goes and talks to the example.net name server, and when it goes and talks to the example.net name server, do you think we can get the answer? Yes, we can, because it is the authoritative name server. This is why I was telling you before, they are the reliable party, they are the authorized party who can give this answer, right? So we get an authoritative answer from the example.net name server, and that is given to the client or the resolver, and then resolver will pass it on to the client. So once this is done, obviously the caching server or the recursive server will also have to prepare for something else, which is that there might be some more clients will come and ask same type of questions again and again, right? There might be another client will come and ask for the same www.example.net. So if that's the case, should the caching server go and talk again to the root name server and .net and so on? You don't need to, right? Doesn't need to, because if the caching server can keep that answer in its cache or the memory basically, then when the new client come and ask the question, the same thing, then it can respond to the client straight away. So this is the caching and how it's happened. So this is where we can improve the performance of DNS as well, right? But again, you will also have to think about, okay, how long, and if you change the things very often, then you don't want to keep very big caches, and so that the answers can get might not be the real right answer, right? So these are the important elements in terms of DNS resolution, right? How the queries get resolved. But the question here is now, when this thing happens, do you think it is secure, right? When this happens, where the problems can occur, right? What are the infrastructure that we deal with in DNS? So these are the questions that we will have to ask, especially looking at from a security point of view, okay? So now, this is where now we are going to actually focus more into the DNS security aspects and DNSSEC specifically, okay? So in DNSSEC, what we are talking about, now first of all, we'll go through the DNS data flow. What is the DNS data flow involved here? Now, there are a number of elements, as I said before. First of all, we write our databases, or the zones, or zone files, right? So we write a zone file, pretty much, right? So you could be writing this manually. Maybe you could be writing your zone file manually, or you could be updating it through a database process. Say, for example, you have a database, and you could be updating the database, and then you have scripts to get the information which is in the database and updating your zone file or your DNS database. This could be another option. So whatever it is, we update our zones. We update our zone files. By the way, when I say a zone, what is a zone? Zone is really your administrative space. That's where as an administrator, as a DNS administrator, that's where you deal with, right? You edit your files, you do your delegations and so on. That's your administrative space. And that's our zone file. So where do you write the zone file? You write the zone file in our master or the primary name server. So that's why you see actually here you have a master there, and then you update your zone there, okay? Then I also mentioned you that there are other authoritative name servers, the secondaries. So that's where you have slaves or the secondaries. Now, when you update this zone update can also happen through what we call dynamic DNS. Either you can, manually do the update, or it can even happen dynamically as well. Either way, what we are doing is we are updating our zone. So when the zone gets updated in the primary or in the master, this has to be replicated into your secondary, right? Into your secondary. Now, during this process, how the secondary will come and get the zone from the primary. So the secondary will go and contact the primary and do a zone transfer. So we call this process as a zone transfer. So the zone gets transferred from the primary name server to the secondary name server. So that is the step 1, 2, 3, basically. And then when the zone gets updated in both primary and secondary, after that, the authoritative servers are all synchronized. They have the same type of data. They are consistent now. Then the caching name servers or recursive name servers out there, they can go and talk to these primaries and secondaries. Okay, they can go and talk to primaries and secondaries and get the answers, get the authoritative answers from them. Okay, so the answers go into caches then. Right, caching servers or caching forwarders, the answers goes there. So when the answers goes there, then the clients can go and query the caching servers, recursive servers, and so on, and they can get the answers from the caching servers. So these are the important elements or the data flows which are involved in DNS. So now if you really have a look at this whole picture, the whole process or the flow, where do you think, if someone want to really attack you, right? If someone want to create some issue like in your DNS infrastructure, where you are vulnerable, where can someone attack you? These are the things that you will have to think about when you work on DNS security, okay? So someone might say, okay, what about writing my zone file? What about if someone corrupt my zone file, right? Things like that. What about how do I know when I do a zone transfer? Say if I'm the secondary, I will go to my primary and do a zone transfer. So if I'm doing that, how do I make sure, how do I know whether it is really my primary? It could be someone else. It could be another server. And the primary might think, how do I know whether this is really my secondary? And at the same time, what about caches? How do we ensure that the data going into the caches are safe? What about if someone pollute the cache, right? Instead of something which really should be there in the cache, and that is changed, right? So that the client will be taken to a wrong place, wrong website, things like that. So all sort of problems can happen, right? So in this slide, you can see that there are lots of, pretty much, everywhere in your DNS infrastructure, you can really get attacked, right? It could be impersonation, cache impersonation. It could be that cache pollution. It could be that, unauthorized updates. All sort of things can happen. So this is where the DNS security will come into the picture. Okay, now, we can't protect everything by one mechanism, right? So we need some, for example, we have to protect our servers, we have to protect our data, and so on, okay? So this, for these different different purposes, we have different mechanisms. If you're talking about protecting servers, obviously now we are assuming here that all your network, physical network, it's all, protected and things like that, right? So after all that, you also have to think about protecting your server transactions. So for those, there are different other technologies, different other mechanisms available, things like signatures, transaction signatures, or TSIG, we say. But talking about DNSSEC specifically, DNSSEC protects the data, right? The DNS data. So that's where the DNSSEC gets involved, okay? So the whole objective here, okay, we are going to now focus more into the DNSSEC, which is actually protecting data. But again, protecting data is just not enough to do everything, right? So DNSSEC is only one mechanism to protect your DNS data. You still have to protect your zone transactions. You still have to think about your security other measures and things like that. But if you are specifically talking about your DNS data, that is where DNSSEC gets involved. Okay? So where does DNS data lives? If you are talking about DNS data, where does it live? DNS data lives in our zones. It lives in the caches, right? Caching servers, and so on. So that's where we have to focus on when we go into DNSSEC. There are so many examples. If you start giving, even if you do a search, you can find there are lots of examples, real-life examples, different types of attacks, and so on. One of the attack which got really went into lots of media and so on was a few years ago, like DNS changer attack, right? So this was this created lots of many millions of systems were affected, and lots of losses, like millions of dollars losses created, and so on. So these are all, the DNS changer was simply that your resolver was changed by a malware, right? DNS resolver was changed by the malware, so you would be taken, if you want to visit a certain website, now you're not actually, then whoever the party that is controlling that resolver can direct you to a wrong website, right? So all these queries, the genuine queries, can go to wrong websites and then get the wrong information. We also, use other technologies even for SSL and so on. One of the other concerns, like when you use SSL, we use lots of CAs, the certificate authorities. So when you use a lot of certificate authorities, what is the risks there? I'm not saying it's totally unsafe, but then there are still risks involved. What sort of risk involved when you have lots of certificate authorities? Because nowadays you have over 1,500 certificate authorities. So whom can you trust? That is one question we have to ask. Because generally, when you think about these certificates, you would accept those. You'd say, I trust this certificate, but really, how can you trust, right? So these are the risk factors we have in terms of SSL and so on. So this is where actually, there are in fact some protocols. There are some developments of protocols like DANE, for example, which is all based on DNS. Okay, so that we can use DNSSEC and then try to validate those correct hierarchical parties. Now, so obviously we have discussed about those DNS vulnerabilities, the man-in-the-middle attacks, and so on. So those are all risks involved. So this is why we use DNSSEC, right? So when we use DNSSEC, obviously we use keys, right? As I mentioned you before, digital signatures. So when we talk about these cryptographic keys and so on, so we'll have to deal with multiple keys. We deal with public keys, we deal with private keys, and then we deal with signatures and so on, right? So in fact, I won't go too much into the key stuff here, trying to explain all the symmetric keys, asymmetric keys, and so on. In fact, even in the previous session, there was some discussion about keys and signatures and so on. Simply what we are doing here is that if I can publish my data, I was talking about DNS data, if I can publish my data, and if I can sign, right? If I can sign my data with a signature, right, a digital signature, then if someone wants to verify that it is really mine, then that can be done by verifying my signature. So how can someone verify my signature then? If someone wants to verify my signature, they can do it by using my public key. So for that, then I have to publish my public key as well. So this is where the public keys and get signatures involved. So then I will also have, obviously, when I generate the keys, I will have private keys, but private keys you don't share, right? So you just have to keep your private keys safe, okay? So some simple example here, just to see, usually, as I mentioned before, when the query comes to a DNS resolver, in this case, if the query is for, say, www.majorbank.id, right? So that will be the query. And then this query goes to the authoritative server, right? The DNS server, the authoritative server. They are supposed to have all those zone records for majorbank.id, so which means the www record is a zone data, it's a zone record. So they will have, say, if they have a mapping for www record to an IP address of, say, 1.2.3.4, right? So that is the correct IP address. And then this correct IP address is given back to the resolver, and then resolver give this answer back to the client, so that the client now can go and talk to that web server, right? And then download the web page. So, and then start working on it. And basically, if it's a banking server, it could be a banking transaction type thing. So you'd be logging into your online banking system. So the client can be giving the user ID, the password, and things like that. So that's what normally we do, right? So once we get into the web server. So during this process, we go through the usual DNS hierarchy, right? So as I said before, we have a hierarchy there. On the top, we have the root servers. And then we have the next level like .id or .com or .net and so on, and then the next level and so on. So we traverse through this hierarchy and get to our authoritative server. Okay, so now where can the risk in all, as I mentioned you before, when this query happens, what if, right? What if some attacker, say, running a wrong web server, right? A bogus web server. In this case, the IP address is 5.6.7.8, right? And then if this answer can get injected into the resolver, say before the actual authoritative server talks, right? In that case, the caching server or the resolver gets a wrong answer now. It should be getting the 1.2.3.4 or IP address, but now it's getting the 5.6.7.8 IP address, which is wrong. That's a different web server. So someone could run this web server somewhere else. Maybe it probably looks like the bank website, exactly. It's kind of a replica of that, but it's not really the bank website. So the user could be giving, the ID, the password, and things like that, and then those credentials can be stored in a database, and then use it for other purposes, right? And then the user could be given an error, obviously, that they can't log in. So this is where actually now we have to think about DNSSEC and how DNSSEC can actually protect this kind of situation. Basically, in this case, it's cache poisoning, right? So if we can then implement DNSSEC, say, for example, in your authoritative server, right? So your authoritative servers, that's in this case, it is for majorbank.id. There are multiple authoritative servers. So if their data is signed, and then they can give the authorized answers, and then if that can be validated, then the resolver, and provided the resolver understands this whole thing, right? If the resolver does not understand, then we can't help much. Okay? If the resolver understands this to how to validate and so on, then the resolver can check whether this is a valid answer. In the previous case, obviously, if someone else is running this web server just looking like the correct bank website, then definitely you can't match those signatures, you can't verify those signatures with the correct keys, so the resolver will not accept that, it will drop that, right? So this is the whole purpose, and then when the correct answer gets into the cache, it can be validated, and also the caching server will keep only the validated answers in its cache. It will not keep the wrong answers in the cache, it will only keep the validated answers in the cache, right? And then obviously the client can go to the right website and download the web page. So this is simply where one simple example how the DNSSEC can come into the picture and try to protect this kind of risk. Okay, so earlier I mentioned you that DNSSEC stands for DNSSEC Security Extension, and we also now dealing with keys, right? We deal with keys, we deal with private keys, public keys, and then we do the signing process, right? Okay, now when we talk about DNSSEC, what are the things, I think I also mentioned about this briefly before, what are the things that it is doing and what are the things it can't really help us. If you think about, say, DNS, like DDoS type of attacks and so on, these things, obviously, DNSSEC can't help. That is, you have to have other security mechanisms in place to, help on those things, right? And also, we have to make sure that our DNS data is correct. Say, for example, if you type something wrong, or if you misconfigure your zone, we can't help there, right? DNSSEC can't help there. But where it can help is where, say, for example, protecting end users from redirections if it's going somewhere else, to a malicious site, just like what I mentioned to you before, right? Things like DNS changer issue that I was talking about before. You are being redirected to a wrong recursive server and then going into a wrong website and so on. And then also DNSSEC can help us, allowing us to validate and whether to make sure the data is all trustworthy data. This is something important. All right, so let's go through now how DNSSEC work, right? Now, if you remember this query process, I was going through this before, but earlier it was not really secure because it was just simply a DNS query. The client went and talked to the resolver. Resolver went and talked to the root server, and root server told you go and talk to .NET server. .NET server said you go and talk to example.NET server, and so on. But now, if you can sign, right? If you can sign your zone and pass this trust, right? Here we are talking about a trust. If you can sign your zone and pass the trust to, say, along this hierarchy, that means to your parent. If I am example.net, if I can sign my zone, right, and pass that trust to my parent, which is .net, okay, then I build a trusted anchor between myself and my parent. And then parent also can actually sign the parent zone. Okay, parent can also sign the parent zone, and parent can then pass the trust to parent's parent. So in this case, .NET will send the trust to the root then. So if we can actually implement this trust path all the way to the top of the tree, then obviously we can implement some trust all the way from bottom to the top of the tree, right? So which means when these DNS queries happen, then with the keys, right, with the public keys, we can always validate the signatures. So that means when you have your DNS data now, the DNS data contains signatures. If we are talking about, say, a record www.example.net has got the IP address or the A record for whatever the IP address. So in that case, this record now has got a signature, right? So whoever the validators who are getting these, the servers, they're getting this answer, now can validate whether this signature can be verified using the appropriate public key, right? So that's what we try to do. So we will use the keys and signatures to validate the data, okay? So now obviously this kind of query, when with the keys and verifications, signatures, and so on, when you add all those things into to your infrastructure, naturally there'll be some, you'll have to think about the performance aspect as well, right? Because now, earlier we did not deal with keys, we didn't have to process the keys, even when you do the zone transfers, it was very simple before. Our zones were not large because it did not have the signatures. But now, yeah, in our zones, zone data contains the signatures, contains all those other resource records. So obviously our zone files have grown, and then validating these things, we have to do some, we have to do those, handle those overheads. So obviously these things you'll have to plan when you think about DNSSEC implementations. So in DNSSEC, how it works, as I told you before, what we try to achieve here is two important factors. One is authenticity, okay? Authenticity. Is it the right party? Authenticity. And then the integrity, okay? Again, something very important. What is integrity? Integrity is whether the things are intact. If someone in the middle has modified something, if someone has modified something, then we lose the integrity, okay? So we try to detect this also in DNSSEC, right? Now, sometimes some people might ask, okay, shouldn't we then encrypt? No, encryption is not something we do here, because in encryption, what we try to achieve is the confidentiality factor, right? Confidentiality. But with DNS, it's all public data, right? It's public data. So we are not talking about the confidentiality factor here. So encryption is not coming into the picture. So what we try to achieve here is authenticity and the integrity, okay? You might find some new resource records when you deal with these things. Now, if you're familiar, I don't know whether you have configure DNS servers and so on. Before in DNS, if you go and open a zone file, you will see resource records. You'll see SOA record on the top, start of authority. Then you will see what? You'll see your NS records, the name server records. Then you will see A records, for IP address mappings and so on, right? So you will see all those records. And then just like that, the type, I was talking about, SOA is a type, NS is a type, A is a type. Just like that, we also have to now deal with few other types of DNS resource records. Say, for example, DNS key. Now, DNS key is a resource record type. Okay, that's a resource record type, DNS key. Why do we use this DNS key resource record type? This is to publish our public keys. I told you before, we have to publish that in our zone, because if we don't publish it, how can someone else verify our signature? So we have to publish our public keys. So how do we publish our public keys? We publish our public keys by using this resource record called DNS key, right? DNS key. And then we also have to publish our signatures, right? Because if we want to publish our data and say, you better verify this, I will publish my signature, right? So how can I publish my signature? There is a resource record for that. That is called RRSIG, right? RRSIG stands for Resource Record Signature. Okay, so new two type of resource record, DNS key, RRSIG. Then we have another new type, new resource record type comes in, that is called DS, right? DS. DS stands for Delegation Signer, right? Delegation Signer. Now, I told you before, protecting yourself is good, obviously, right? But it's not enough. You have to propagate the trust, right? You have to propagate the trust to where? To your parent, right? You need to propagate the trust to your parent. So when you propagate the trust to your parent, how do you do that? You do that using this resource record called DS, right? Delegation Signer. So DS is simply actually, it is a hash of your public key actually, right? So you are propagating that public key, the hash of that, to your parent as the form of a DS resource record, right? DS, Delegation Signer. So which means if you are the parent, someone else is the parent, parent has to have the ability to accept child's DS records. If I am .NET, right? If I'm .NET, I give you example.net, right? You are my child, right? You are example.net. So if you secure your zone, right? If you sign your zone, now you will have your public keys. So you have a hash of that. That is DS record. Now you need to give me your DS record so that I can publish the DS record in my zone, right? So which means I have to have some mechanism to accept your DS records. So I could be having maybe a database to, and then give you a web interface, and so that you can, log in and update the DS records and so on, right? So this is kind of a typical way. And then this needs to be repeated. I can't just stop here. I have to do the same thing. I have to give my DS records, once I sign my zone, my DS records to my parent, which is root, right? So this is the process involved in DNSSEC. And also, this is why sometimes the things get complicated also. And also it is, you'll add some little bit of overheads here, because you have to interact with your parents often, and you have to deal with your parent often. You have to give the DS records and so on. And when you change your keys, you have to let the parent know, things like that. So that's something that you have to deal with. Some organizations might find, business cases. Why do we think that DNSSEC? Why should we go for DNSSEC? Or why should we implement this and so on, right? It is, in fact, it's not something came a few months ago or last year, or it has been there for quite some time, right? More than 10 years or so. And so there are lots of work has put onto DNSSEC. Lots of research work has been gone into DNSSEC. Lots of IETF work has gone into DNSSEC, right? So people won't do that just for fun and things like that, right? So there is something useful, right? It is very useful. That's why actually, first of all, if you want to think about those security risks that we discussed before, the vulnerabilities, the risks, and so on, DNSSEC is a very important mechanism to protect those infrastructure. This is something that you have to think and actually, have it in your business case. There has been a lot of work has gone into this all over the world, right? And also, it is a competitive advantage as well, because, for example, if I'm selecting, if I want to get my domain from some registrar or ISP or DNS service provider and so on, I would always prefer to go to someone who has secured the things, right? So if you secure your zone, definitely you'll have some competitive edge over someone else who has not done that, right? So that's where you have some advantage. Now this is just a snapshot of CCTLD's perspective. So CCTLDs are the country code top-level domains, like as I told you before, like .id or .sg or .au and so on. So this is just a snapshot of the whole world, all the green areas. That's where actually all the countries who has signed their CCTLDs, right? So it's pretty good. If you see all over the world, it's all pretty good, except in some regions and some sub-regions, but generally it is okay. If you see statistically, it's about 80% or so. About 80% of the CCTLDs, they have signed their zones, including .id. Here I'm focusing especially on Indonesia here. Now these are again some further statistics on TLD level, right? So this is on TLD. So you can see actually, based on the last 3 years, now we are in 2015, around from 2013, right, late 2013, suddenly this, before that, it's all very slow pace. The TLDs did not go in very rapid rate. They did not sign their zones in a rapid rate. But we could see that in the last 3 years, suddenly the curve is going, in very high, steep curve. And why? Probably, this is one thing. Obviously, there has been a lot of work going on all around the world on DNSSEC. And also the other thing is now, I was talking about ICANN before. So at ICANN, with our new RAA, which is the registrar, the accredited agreement. So in this RAA, this contract, the agreement, DNSSEC, there is one clause on DNSSEC, especially like new GTLDs and so on. They have to deploy, right? So this is one of those conditions as well. So that is why you can see that in the last few years there has been lots of DNSSEC signing as well, comparing to early days. So this is also some statistics on how many zones, how many TLD zones have signed at the root. And also sign their zones as well. So generally, as I said, it's around 80% or so. But the question is actually, okay, some further stats here, .com, .net, and so on. So generally, it's kind of the same type of curve. Last few years, people have taken a lot of efforts. They have signed their zones, .com. Now, these are some country codes, top-level domains, some few CCTLDs who has done quite a lot on DNSSEC as well. Yeah. Now, the question is, beyond that, so we say, and also root is all signed. Root is also signed, okay? So root is signed, CCTLDs, the TLD is almost like 80%, they're okay. But what about the rest? Beyond that, right? What about something.com or something CCTLD, these kind of the next level domains, right? Beyond that level, what about them? It's not much. Statistically, it's around less than even 12%, right? So it is not much. So there's lot of work has to be done there, and that's why actually you have to think about it, right? So you are managing, you could be ISPs, you could be domain name registrars, you could be other service providers, you could be even enterprises, you could be financial institutions, Yeah, you have to think about this aspect, right? Think about protecting your zones. It doesn't mean that we are telling you go and tomorrow start signing your zone, right? You should try to do some test first, work in your test environments first and see, the things you can all okay. As I mentioned you earlier, like measure your performance. Yeah, you have to do all that for a while, and then if everything goes fine, then you get to the stage where you can actually sign your production servers, right? So when when we speak to some of the people, they give different answers. Sometimes they said, okay, we don't have enough skills. Our IT staff don't have much of enough skills. So this is where things like training and all that is quite useful, quite important. This is obviously a very concise tutorial here we are doing. We are trying to do everything in like 1.5 hours or so. But typically, we would be doing kind of a hands-on type workshop. We do that, right? We do that with ICANN and with these type of sessions and also various other RIR meetings, APNIC meetings, APNIC sessions. We do lots of these training activities, workshops, and so on. So try to participate in those. It could be maybe, these are like, I'm talking about like longer version workshops, like you're talking about like 2 days, 3 days, and so on, where you would really do all the hands-on and signing and everything, right? So these are things that you can think about, especially if you think that your staff is not skilled, or if you want to get more knowledge and things like that, right? Some people also, they say that, oh, we have heard a lot of stories and we have this FUD, what is FUD or FUD? Fear, uncertainty, and doubt, right? So people have all the fears about it and uncertainties about it and doubts about it. So yeah, that's why, again, we all here, we can all support you, help you, write to us, and so on. So we can help you out. And also sometimes some people say that, oh, our clients are not asking much about it, so we don't need to. And then when you go and ask the clients say, oh, our ISP is not providing that service, so we can't help much, right? So, so it's again kind of chicken and egg problem as well. So somewhere it has to stop. So take initiative, take the initiative and be proactive. That's quite important. Right? And as I told you before, now it is required in the new ICANN registrar agreement also. So as organizations, as individuals, and in general, what can you do actually? If you are from a corporate, if you're from a company, and so on. Basically, sign your zones, sign your domains, and then also try to validate your resolvers if you have. Now, we are talking about two things here. One is, if you remember, in the beginning, I was talking about the DNS resolution process. I was talking about the recursive servers. I was talking about the authoritative servers. So, two things. You run your authoritative zone. So that is, if you are managing example.net, you have to give authorized answers for that, right? So that is where you will sign the zone and you deal with all the keys and so on, right? So you have to do a little bit of work there. But then the other aspect is, if you are providing the recursion to your clients, you could be ISP, so you are having your DNS server, so when your customers, when your client come to you, you are providing them the recursion or the recursive service, right? So this is where at least you should try it out, right? Because that doesn't, you don't need that too much expertise there, right? So here you're talking about only your caching servers, the recursive servers, the resolvers. So when the clients come and ask questions, what you just need to do is just validate their answers. So next step, possibly, you can go and sign your zone. That's where the authoritative server signing would come in, right? All right, so if you're a user, even can talk to, as I said, go and talk to your ISP and say that, we would like to have DNSSEC validation, right? Can you turn it on in your resolvers? So DNSSEC, that's an internet infrastructure upgrade to help address today's needs and create tomorrow's opportunities. That's a good saying, okay? So now we talked about all this trusting process, and we talked about propagation of trust. So we send the DS to from ourselves to our parents, and parent to parent, all the way to the root. So root has the root keys. But now the question is, okay, how can we trust root, right? Can we trust root? Can we rather trust the keys? Now again, there is a very well-established, proper process involved in this whole thing, right? The root keys and the signing process, the party, and so on. And so this is done at IANA, right, which is a function of ICANN. So if you go to IANA website, you can actually find more information about this process and which time frames it's happening, the key signing party, and again, this is not something done in a hidden place by hidden people and things like that. So it's an open process. The community is involved, right? So there are a number of crypto officers from the community who are knowledgeable about all these things, right? So there are all over the world, there are lots of crypto officers, right? So they get to one place and they do this signing process, and then so they at the witness of everyone. And again, these sessions are all webcasted, so you can even watch this happening through webcast, and as I said, you can see the schedule and all that, okay? Some pictures, I got from Rick before, so, this is where, how this process happened. But as I said, this is all done in webcast, so you can even have a look when the next ceremony is happening, right? So as it's all a community process. So these are all crypto officers. They come and go through this key signing thing. Okay. All right. So I'll try to, given the time, I'll try to, quickly go through a few more things about these new resource records as well, and what we do. And hopefully, if I get a little bit of time, I'll just quickly show you with a quick demo so that you can get an idea, right? So we are trying to create all these secure entry points and chain of trust. That's where you propagate the trust. There are some new flags. I don't know if you have done some DNS queries before, you might find, if you do a dig, right, there are some flags, whether it's an authoritative answer or whether it's a recursive and things like that, are little flags. So you might find there are some new flags as well over there in the packet options. CD, which is called checking disabled, so in case if your server does not understand DNSSEC. Then we have something called AD-bit. So AD-bit stands for authenticated data, so which means when you get the answers, you can see, okay, if the AD-bit is set, we know that the answer is authenticated, it's verified, right? That's going through all that hierarchy, and it's all done. But nowadays, if you want to do it, say, as a client who doesn't know all this stuff, you simply what you do is you just install the validator in your browser, right? It could be coming as a plugin, for example. So you install a validator in the browser, and then, that will do the rest, and you can see a little lock kind of thing, or a little key, so that, okay, this is, if I'm visiting a certain website, I know this is DNSSEC secured. Okay, this zone is DNSSEC secured. DO bit, so this is DNSSEC OK, right? So these are all having some flags and so on. Now, new resource record I was talking about before, DNS key resource record. This is to publish the public keys. RRSig resource record signatures. This is to publish the signatures. We also have something called NSEC. Now, NSEC stands for Next Secure. What is NSEC? I told you about integrity. Remember, protecting the integrity, or making sure that your zone data is all intact. If you have done some change and things like that, that has to be detected. So this is why we have this new resource record again called NSEC or Next Secure. But you don't have to add all those things manually, right? Because during the signing process, these things will be added into your zone. So you don't need to work with these manually, right? Recently, there was another upgrade to that new version, that is NSEC 3, because NSEC, there was some possibility of doing something called zone walking. So that means what happens is really when you talk about integrity, what it does is it will kind of link or chain all your resource records. So all the resource records inside a zone will be linked and chained. So that in case if something is removed or something is modified and so on, we can always identify that. But then someone can also use that feature to do something called a zone navigation or zone walkthrough, right? So this is why actually they came up with a new version for that called NSEC 3, where we have hashes, so you can't even then find those. So that's another new version. DS, I told you before, that is delegation signer, where we send the propagation of trust. We send those hashes of your public key to your parent. We also have to deal with signature expiration, right? That's something that, again, has to be properly managed because, the keys can, the signatures can expire. So we need to, at proper time intervals, we have to actually generate new signatures. Key rollovers, these are something quite challenging as well, has to be planned properly because we should not be keeping the same keys over a long period of time. We should be changing the keys. So if we change the keys, then we have to do these key rollovers. All right, so simply, in chain of trust, I think I already mentioned you this before. What we try to do is we establish a secure channel or kind of secure trust anchor or a secure entry point between the parent and the child, right? So that's what we try to do. And then we send a hash of our public key to our parent, and then parent can actually put that in the parent zone and sign the parent zone. So how does these new resource record looks like? All those resource records that I was talking to you before, how do they look like? Now, this is how the DNS key resource record looks. It is actually your public key, right? Remember, DNS key resource record is used to publish your public key. So if you have a look at this example, now usually in a resource record, we have 5 fields, right? Simply, if you take, say, any record, SOA record or NS record or A record, you have 5 fields. What are those 5 fields? You have a label in the front, right? That's, say, you have a label, and then you have a TTL, or we call it time to live, right? Time to live TTL value. Then you have something called a class. You may have seen that IN, that's the class. Then we have the type, resource record type, and then finally we have the resource record data or R data. So all those 5 fields still exist here. So if you see the owner, that's the label. So in this case, the label is example.net. You have to put these labels in a fully qualified domain name. Fully qualified domain name means you all the way refer to the top of the hierarchy. So the last dot that you can see there, the last dot, so that refers to the root, right? That's what we call a fully qualified domain name. So the next field is TTL. Then we have type, which is our resource record, DNS key resource record. There are some flags there. They all come under the R data or resource data. Now, this flag is something to observe. Say, for example, later on, when we talk about DNSSEC, we'll deal with multiple keys. So some of these flags will refer to, what type of key that you're using, what type of algorithm you're using, and so on, right? But actually, if you have a look at here, that's your public key, the long one, right? So that's actually your public key. And then we also have something called a key ID. So that's how we generate. So we have to generate these keys and then publish these in our zone file. That's what we do. Okay. Now to make the things more complicated, now we have to deal with further key pairs, right? Why do we have to do this? Because if we try to deal with only one key pair, which means we have a private key and a public key, we send the public key to our parent, and parent signs that, parent send it to parent's parent, and so on. But then, if we have to do any changes to that, then you have to go and always disturb your parent, right? So this is where, but we don't want to, practically in real life, we can't go and all the way disturb our parent. If I'm example.net, I can't all the way go and every time disturb my .net, this is my new key, and so on. So we generate another key pair for this, and this is what we call the, there are two acronyms for that. One is called the, this talks about the first key pair, right? First key pair. So we have a private key and a public key. And then later we will get to the key signing key, which is the, so we have two keys, as I said. One is called zone signing key and the other one is called key signing key. So zone signing key we use to sign our zone, right? And then key signing key, then this is the key that we send to our parent, right? So we deal with two keys. Which means two key pairs, basically, right? So in this way, if we manage two keys, we can, we don't have to go and disturb our parent all the time. That is also one good advantage there, right? So we can have different signature expiries. So for our own zone, we'll have maybe a shorter expiry of that. That is the zone signing key one. That will have, the signature will have a short expiry, whereas for the signature in the key signing key, we will have a long expiry, so that we don't need to go and actually disturb our parent all the time. So that's why, sometimes if you see, those flag values which I was talking about in the public key, the early example showed 256, because 256 is the value for zone signing key, and 257 is actually for key signing key. So those are the two different type of keys that we use. So this is how the resource record looks like, right? Resource record. So the RRSEC resource record, the signatures. So how do we publish these signatures? We publish using the RRSEC resource record, and this is how it looks like, right? So again, it's a resource record. We have 5 fields. We have a label, which is example.net. Then we have TTL. Then we don't have the class here because class is default class, so IN is dropped there. But then we have the type, that is RRSEC, and then the rest of the stuff is all our data, or the last field of that. So here also you can have number of parameters. If you properly observe, you will see even the signature validity, right? I told you, the signature is valid, it's valid only for certain duration. So in this case, it is valid for something like 3 months, right? From October to January, something like that. So it refers to that time frame. And then it also talks about what zone that we have signed. In this case, it's the example.net zone that we have signed. And then the last part, that is actually your signature. That is the signature. Remember, this is not the private key, right? Don't get confused here, because using the private key, we generate this. We sign the zone, and then this is our signature. So we never publish, of course, the private key, right? We have to keep the private key safe with us, but we publish our public key, and we also publish our signature. All right, so that's all RRSEC. And so keys do not expire. If you don't want to change the keys, you can still go, but then it's not a good idea either. You should change the keys time to time. But then signatures do expire. Remember the NSEC we talked about before, that also handle these NX domains that prove. Say, what do you mean by NX domains in DNS? NX domains are like negative answers. So if there is not, if it doesn't exist in our zone, say I have example.net, but if there's a query for something which does not exist in my zone, so that I have to prove that, right? This does not exist in my zone. So that is where the NX domain comes in. So we can use an NSEC resource record to secure that. As I mentioned you before, this is where we try to achieve the integrity of our zone file. So our zone, all our zone records are linked, right? They are linked to each other. So which means if you see one type of resource record, it will say what is the next resource record coming after me and what resource records types were before me, so that we establish that chain or the link between those, right? It's kind of a link actually. But during this process, your zone file has to be sorted as well, because if your zone file is not getting sorted, say, there are several rules. It will be sorting alphabetically, it will be sorting based on the number of labels and so on. So there's a sorting process, and then after that only this linking will happen, okay? So in NSEC 3, again, we don't see those in plain text. They're all kind of hashes. So if someone doesn't have to actually go through and look for all those things and do any zone walking. That's why we have NSEC 3. Okay. Delegation signer, I have talked about that as well. I know it's like 12:30, but I'll just take maybe another 10-15 minutes possibly, right, and just try to quickly finish it off. So this is actually the DS record, how it looks like. Right, DS, that's where we propagate the trust to the parent as form of DS. Okay. I'll try to quickly show these actually with a quick demo so that you can get a feel of these. Signature expiration, and I mentioned that this is something that properly have to be planned, right, and then do the key rollover, right? Do the key rollover. Why do we have to worry about a key rollover? Because and also actually one more thing, when a key rollover happens, right, you can't just remove one key and put another key. What's the problem there? Why can't I just remove one key and then just put another key? Because DNS data will not straight away propagate from one place to the other place straight away, right? It takes time. If I do something here in my authoritative server, I might have another secondary server somewhere else, in another network, in another country. We might have so many other recursive servers around the world. So to propagate all this information, it takes time. So that is why if I'm going to change something, if I just remove, if I generate a new key and try to, put my new key here, but still out there, there are still other resolvers, other servers, they're still using my old keys. So that is why we can't just remove the old keys straight away. So this is where we need the rollovers. So this rollover process has to be planned properly, right? So there has to be some kind of transition period. So old keys and new keys have to exist at the same time for a certain period of time based on your TTLs, right? Because TTLs, that's where the answers live in the caches for that long time, right? Time to live. So if it is like 1 hour, that means when the answer goes into a cache, that will stay there for 1 hour, right? So we have to think about all those aspects. That is during the key rollover process. Okay, now let us try to go through a summary of things. Generally, what you have to do, say, if you have to start signing your zone, right? First of all, you have to enable DNSSEC, right? You have to enable DNSSEC, and again, here you have to think about what type of DNS name server that you are using. You could, if you are running some very old DNS servers, I know in some places, some organizations, even in some CCTLDs, they could be running some very old name servers that may not support DNSSEC, right? If that's the case, you will have to make sure that you have a version that you can support DNSSEC, right? So upgrade your name server software and make sure that it can enable DNSSEC, it can validate DNSSEC. Then what you do is you just create your keys. Now for this you can use various key generation mechanisms, algorithms, utilities, right? So there are, for example, with bind, we have a utility called DNSSEC keygen where we can use to generate our keys. So when we generate these keys, we have to generate, remember I was talking about the zone signing keys and key signing keys. So you will need to generate both of these keys. So that's the next step. And after this, you will have to publish your keys, right? Publish your keys. So where do you publish the keys? You will publish these keys in your zone, right? If you're dealing with your own zone, you publish the zone in your own zone, right? And then you sign the zone, right? Sign the zone. Again, for that we have utilities. So in this case, in bind we have, I'm just taking some examples from bind. So we have utility called DNSSEC sign zone there. So we will use that. And once you do all those, now you will have to go and update your configuration file. Your configuration file, usually again in bind we call it as named.conf. So you will go and update your configuration file, the named.conf, right? And then you can do a test and see whether it's all working fine. So these are simply, again, the test involved, but there are lots of other things that you will have to think about along with these things. As I mentioned, key expiry, the signature expiries, key rollovers, and so on, right? So that's a kind of summary. So what I'll do is I'll take another, say, about 5 to 10 minutes, max 10 minutes, and I'll show you a very quick demo so that you can get a feel. Sorry, I had to kind of, rush a little bit because we also started because the previous presentation went till late, and then the tea break got late. So, but hopefully, I can take maybe in 5, maximum 10 minutes, I can show you this. All right, so let's kind of, I'm just trying to, run a very simple name server. So I have created a zone file, my own zone file. So my zone file name is db.myzone. Can you all see this from the back? All right, myzone.net. So this is my zone file, right? This part, just simple. Don't worry about this include statements here, but so you have, I have my zone records, I have my SOA record, NS records, A records, COD A, whatever it is, right? You have your zone records. So that's my zone file, right? myzone.net. And then I have my configuration file, which is named.conf. Okay, let me clear this. So that's my configuration file. So here I have put, DNSSEC enable yes, DNSSEC validation yes, okay. And then I have a zone statement for my db.myzone.net, because that's my zone file, the file that I showed you before, db.myzone.net, okay. So now let's go through this signing process. Now, first of all, I told you that we have to generate the key pairs, right? We have to generate the key pairs. So how do we can generate using, first of all, let's generate our zone signing key. So we have a utility called DNSSEC keygen. That's the utility, right? And I will use algorithm. Now here I'm using a asymmetric key algorithm. In key algorithms, we have symmetric key algorithms and asymmetric key algorithms. This one is not a shared key, right? We have a key pair. We have a private key and a public key. So that means that's an asymmetric key. So we will use an asymmetric key generation algorithm for that. Say, for example, RSA SHA-1. And then we give a bit value. Now this bit value is to, if you give a large bit value, your key will be much stronger. And if you give a small bit value, your key will be not that strong, of course, right? So I'll give, say, 1024 bits. And then these are some flags just to refer to my zone. So my zone is actually myzone.net, right? Myzone.net. So this field, when I do this, now you saw that it generated a key pair now, right? So it generated this. So remember this key ID. Key ID is 52617. So now if I give ls, you can see now two files got generated, right? These two files got generated. So these two files I'm talking about, right? So these two files got generated based on this key, right? Based on this key. And then if you see the extension of these files, they are one having a what? .key extension. If you see, one is having a .key extension and the other one is having a .private extension. So if I go and open this, .key. So that's actually, remember the DNS key resource record that I talked about before? So that's your resource record, right? DNS key resource record, and then 256. So this is actually our zone signing key, and then this whole thing is what? It's our public key. That's our public key, okay? So we have done the zone signing key generation. So let's now do this for the key signing key as well. So I'll use the same key signing utility, DNSSEC keygen -a, RSA SHA-1, that's the algorithm. This time I will give a larger bit value than before, because now for key signing key I want to generate a stronger key, because that's the one that I want to send it to my parent. So I don't want to go and change it all the time. So I want to make a strong key for that. So let's give 1400 and some flags. This is to specify whether it's a key signing key. And what else? Specify my zone. So what is my zone? That is myzone.net, right? So I will do the same. So now it generated that. Sometimes actually, when you try to generate these keys in your system, it may not happen anything. You just keep on watching what's happening. So this is where you have to give some, some entropy or give some randomness, right? So we got the other key as well. Do a ls minus LA. And you'll have now the other key pair as well, this one, right? So remember that's 68, that's our key signing key. So we generate our zone signing key and then we generate our key signing key, okay? So let us then, what we have to do is go and update our, these resource record. Remember when you open this file, okay, let me open the .private as well and show you that. So .private. So this earlier we opened the .key extension file, which is our public key. Now this one is actually your private key, right? This is your private key. So this has to be safe. You should not change this. This one has to be safeguarded. Okay. So lay this out, and so let us now do this for our. Which one? So we'll now include these public keys. So where do you find the public keys? Inside the .key extension file, right? Inside the .key extension file. So now that means we have to take those resource record, DNS key resource record, and put that into our zone file. So what I'm trying to do is simply I'm going inside my zone file. Let me note down these numbers. 02068, that's my key signing key. Let me note it down, 02068, 02068. and other one is 52617. 52617, that's my zone signing key, right? So let me now go to my zone file, right? I'll go to my zone file, that is db.myzone.net, and I will now, that's what I'm doing here. See, $include, I'm calling that file, .key file, right? I'm calling that .key file, which means actually simply I'm getting the contents into my zone file, right? So let me actually just update this number here. So that was 52617. So that was 52617, and then the other one was 02068. Zero two zero six eight. All right. So let me save this. Okay. So I have now included my public keys, right? Those two, key signing key and the zone signing key. So let us now go through the signing process. So I'm just again here just for you to see this. I'm using a utility called DNSSEC sign zone, right? Again, this can be also automated, right? In fact, with some of the new versions of your name server software and so on, some of these things can be automated, right? DNSSEC sign zone, I'm just using so that you get a feel what we are really doing here. Okay, so -O, you give your zone name, that is your myzone.net, and then you give your key signing key. If you remember your key signing key, that was, what was it? Key myzone.net. That was plus 005 plus. Plus 02068, 02068. Okay, that's your key signing key. And then give your zone file name. My zone file name was db.myzone.net. And then give your zone signing key, which is myzone.net. Is it typing mistake? Okay. Sorry? Oh, okay. Sorry. Can't scroll. Sorry, very hard to type from one hand. I'm holding a mic in the other hand, so. So that's zone. Zero 2068, 02068. Okay. And then my zone file, which is db.myzone.net. Is okay? Yeah, that's fine. And then key myzone.net. Okay, and and the number key ID was 52617. Right. All right, so what I've given is, so I'm signing, so DNSSEC sign zone, and then my zone, the key, my key signing key, the KSK, the key signing key, and then I have my zone file name, and then the zone signing key, okay? So I enter this, you can see now here. So verifying the zone signing, this was the algorithm I used. Zone signing is completed. There is one zone signing key is active, one key signing key is active. Now, remember if you see earlier, my zone file name was db.myzone.net. But now it has created a new file called db.myzone.net.signed. Okay, so you see a new file now. So let's do ls now. Right, ls minus la. So look at here now, right? Okay, maybe I'll just get it up. So have a look at the size. So this is my old zone file and the new zone file, the signed zone file. If you see the size, previously it was something like 329 bytes, but now it has increased to something like what? Yeah, 4,000 something. So more than 10 times, right? More than 10 times it has increased. Why it is increased? Because we have. So if I now remember my zone file, what did I have in my inside my zone file? This was my original zone file, db.myzone.net. So this was my original file. Let's have a look at the signed zone file. .sign. See, now here, during the signing, what has happened? It created all these RR6. What are these RR6? They are all resource record signatures, right? Resource record signatures. So you can see that, so this is the RR6 for SOA record. And this is the RR6 for NS record, and so on. Right? And then you will see the NSEC records here. Remember that for the integrity, NSEC records. DNS key. What is this DNS key? That's your public key, right? We have two. One is key signing key, and then we also have zone signing key. So if you see the flags, 256. So this is your zone signing key with this key ID, and then this one is your key signing key with this key ID, right? Yeah, so the other one, okay? So, all right, and then you go all the way, that's your other zone records and so on, right? So anyway, now, go back. If you now also observe, during this process, there's a new file is also created. What's that called? DSSET. Right, DSSET. What do you think of this? Let's open and see. What's those? DS records. Remember DS records I was talking about? DS records, right? So DS records are hashes of our public key. So these are the records that we have to send to our parent, right? And then parent has to publish this DS records in the parent zone, and then do the same thing, sign the zone. Parent will sign the zone. And then they will also get their own DS records. And that has to be passed to the root, and so on. Okay? So simple as that. So now, let us actually now quickly run our name server, right? Oh, hold on. I have to do one more thing. Go into your, what? Configuration file. Because previously in my configuration file, we were referring to my usual old zone file. But now here I have to change this to the new signed zone, right? That was .signed. Okay, so let's change that. Okay, now let's run our name server. I'll just use just run in the foreground so that you can see the error messages and all that of all the messages. Right, don't forget about all the other stuff. Have a look at here. Now myzone.net has been signed, it's loaded, and DNSSEC signed. It's saying now DNSSEC signed, right? So which means now I have signed my zone, right? So let us now do some query. I'll open a new tab. I just do a dig. Right, so now I'm running a name server, right, in my machine. So I call it as localhost. So I'll tell my machine, otherwise it will go for the DNS server in this network, right? So, and if I now look for, say, www.myzone.net, now this was my web server, right, the record. Now if I do this, okay, somewhere it is not happening. Let's have a look. Right, let me have a look. I think I'm running 2 instances, so I'll just kill one of those. Let's kill both. All right, let us run again. Let us run our name server. So this, I killed it, so I'll rerun that. All right, it's running, it's all fine now. So let us do a dig again. Dig at localhost. I want www.myzone.net. Okay, now it's working, right? So now I get the IP address of my web server. But I don't see those signatures and all that. Why is that? Because I'm simply, my query is just simple query. It's not DNSSEC enabled query, right? Because, if I'm a recursive server, I could be getting queries from normal, clients who do not understand DNSSEC also. So for those clients, I will reply just normal, right? Normal way. But if I get a query from a client who understands DNSSEC, right? Say, who understand DNSSEC, say DNSSEC. So someone who understands DNSSEC, I'll just try to format it properly, so I'll put it into multi-line. Right, and let's see this query now. See, now I get the answers with all the signatures, right? So what you should be, basically, this is a very simple demo. I know it was quite tight time, but hopefully you got some idea, right, what's really happening. So this thing can be, again, as I said, can be automated. Even you can have a little plugin or resolver installed as well, so that your browser can do this whole thing, right? If you're implementing, then remember those flags that I was talking about before. And you just have to know, after this, you have to propagate the DS records to your parent and so on. So that's the usual process. So I don't want to actually keep you for longer, right? We are almost, otherwise you'll miss your lunch as well. But if you have any questions, I think take it later, offline. I'm happy to stay here and answer during lunchtime or even, in the class. Okay? Yeah, thanks very much. Hope it was useful.